This is our momentum video 4 lesson, and we're going to start with these questions. So let's look at number 45. A bullet of mass m and speed v passes completely through a pendulum bob of mass m as shown. The bullet emerges with a speed of half of its initial velocity. The pendulum bob is suspended by a stiff rod of length L and negligible mass. What is the minimum value of V such that the bob will barely swing through a complete vertical circle? So the velocity V is not given. What you have is the mass of the pendulum bob. They tell you that initial velocity was V of the bullet and the final velocity is 1/2 V, but you do not know what that V is equal to. And then they do tell you the mass of the bullet and they tell you the length of the rod. So the information that is not given, the velocity of the bullet before and the velocity of the bullet after. So what I can do, I can use conservation of momentum to figure out the velocity of the bullet after, because the potential energy of the rod or the bob will depend on its potential energy will depend on its kinetic energy. So if I say that after the collision, the bob is moving with some velocity b, I can find what that velocity b is equal to. So I'm gonna say conservation of energy, kinetic energy of the bob will go into the potential energy of the bob. Kinetic energy of the bob is 1/2 its mass velocity of the bob squared is equal to mass g, and the height it will go to is twice the length of the string. So the mass and the mass can be cancelled, and I see that the velocity of the bob is equal to 2 square roots of Lg. Now, since I know the velocity of the bob after the collision, I can figure out what the velocity of the bullet was by using conservation of momentum. So at first I used conservation of energy. Now I'm going to use conservation of momentum. So for conservation of momentum, I say momentum before is equal to the momentum after. Momentum before is the mass of the bullet, velocity of the bullet, plus the mass of the bob times its velocity before the collision equals to the mass of the bullet after, well, the same, and the velocity of the bullet after. It's half of the velocity of the initial one. And then plus the momentum of the bob, mass of the bob, and the velocity of the bob after is 2 the square root of Lg. I'm going to subtract this term from both sides. So mv minus 1/2 mv will give me 1/2 mv. And that is equal to m times 2 the square root of Lg. And to solve it for velocity of the bullet, I have the velocity of the bullet is equal to 4. Then I have the mass of the pendulum divided by, or the bob, divided by the mass of the bullet. And then I have the square root of L times G. And that will be my velocity of the bullet before it collided with the bob. Here's the next question we will look at. In the figure below, or on the side, a 3.5 gram bullet is fired horizontally at 2 blocks at rest on a frictionless tabletop. The bullet passes through the first block with a mass of 1.2 kilogram and embeds itself in the second. So it stays in the second one with a mass 1.8 kilogram. Speed of 6.3 meters per second and 1.4 meters per second respectively are thereby given by the blocks So the velocities of the blocks after the collision will be 0.63 for the first one and 1.4 for the second one. Neglecting the mass removed from the first block by the bullet, find the speed of the bullet immediately after it emerges from the first block and the bullet's original speed. So again, because the energy is not conserved for the first collision, neither for the second one, because it is the bullet damages the block, so some of the energy was lost from the bullet into making the damages to the block. I'm going to do conservation of momentum for the second block. So I'm going to start with the second block before I solve for the first block. So if I start with the second block, I'm going to say momentum before. So let's call bullet. This is initial velocity. And the mass m sub 0, this is m1, this is m2. Velocity v1 is going to be 0.63, and velocity v2 is going to be 1.4. So for conservation of momentum for the second block, I have the mass of the bullet, velocity of the bullet after it leaves the first one, I'm just going to call it vb, plus the mass of the second one, which is not moving, velocity of the second one, so momentum before, is equal to the momentum after. They stick together, so I have m2 plus m sub 0, and they both move with the velocity of 2, which is 1.4. So let's plug in the numbers. We have mass of the bullet, 0.0035 kilogram. Velocity of the bullet after the collision with the first one, we do not know, we're looking for this, and equals to the mass of the second one is 1.8. If I add 1.8 and 0.0035, I get 0.035, and the velocity of both of them after is 1.4. So from here I see that the velocity of the bullet is equal to 721.4 meters per second. So I found the velocity of the bullet after it emerged from the collision from the first block. And to find the momentum, and to find the bullet's original speed, I can do momentum before, momentum after for the first block. So for the first block, I will have mass of the bullet, initial velocity of the bullet, plus mass of the first block, velocity of the first block at first is 0. And then the first block is moving with the velocity v1, momentum of first block after the collision, plus the momentum of the bullet after the collision, and velocity of it after the collision is vb. So I have v sub 0 is equal to m1 v1 plus m sub 0 v sub 0, or vb, and divided all of it by m sub 0. So that will give me, so here I plug in the numbers and I find that v sub 0 is equal to 937.4 meters per second. So that is my initial velocity of the bullet before it collided with the first block. Here's the next question I want to look with you, and you can do this question through Monterey Institute of Technology. If you Google Monterey Institute of Technology and AP Physics 1, and under the momentum, you will see the videos and lessons, interactive videos and lessons, which are amazing. And you also see them in the link in my webpage and in our learning links. I think if you just do those videos alone, you in practice questions, you will get at least a 4 on AP exam. So for this question, we have a ballistic experiment can, and it's interactive problem. So every time you reload the problem, it gives you different numbers, so you can solve it many times, and it shows you how to solve, and it teaches you conceptually, practice-wise. I really recommend those videos. Okay. A ballistic experiment can be performed by shooting a bullet of mass m sub 0 of 0.01 kilogram into a wooden block of mass m. That initially is at rest on a frictionless support of height 1.25 meters. The bullet remains in the block after the impact. the experiment ran twice with the different masses of the blocks. So we have M1 is 0.3 kilogram and M2 is 0.4 kilogram. And the blocks land at different distances. So for the first 0.3 kilogram, it lands distance 1, and M2 will land at distance 2. The difference between the distances is given delta D equals to 0.55 meters. Use the given information to calculate the speed of the bullet if it remains in the block in each experiment. So pause the video and try to solve this question before you watch the video, because it's really worth to practice these questions without watching and learning from problem solved for you. You want to try your best to solve the question before you watch the videos. So in the classroom, you always see me write what is given first before I solve the question. Here, because of the limited space on my iPad screen, so I try to underline everything that is given, but I usually would start with writing down everything that is given. So if you have a block right here, and the bullet is shot into the block, so we will say here is the bullet, and it has initial velocity v sub 0, and the mass of it is m sub 0. And here is m. It's either m1 or m2, one of them. And after the bullet gets into the block, it stays in the block and lands. If the mass is lighter, it's gonna go farther, and if the mass is heavier, it's gonna fall closer to the stand. And the stand height is h. Because I know the stand height, I can figure out final velocity. So what I can figure out is this v final. So to find that v final, I have to do the square root of 2ad, because I know the distance and acceleration due to gravity. So I have the square root of 2 acceleration due to gravity in the distance it travels vertically. So my horizontal velocity will not change at the collision. So this is going to be v. The one that is landing farther is v1, and the one that is landing closer is v2, because it's heavier. So this is mass 2, and this is mass 1. So if I plug in my numbers, I have the square root of 2, g is 10, and the height is 125. So I get 5 meters per second. That means the blocks will land. So the time it takes for the blocks to land is the change of the vertical velocity over the time, over acceleration. So I'm using acceleration formula, so it's change of the velocity over the time, but I'm solving for the time. So I have change of the velocity over the acceleration, and that will give me 0.5 seconds, because initial vertical velocity is 0, final vertical velocity is 5 meters per second, and the change of it over g is 10 gives me 0.5 seconds. So I know how long it will take for them to land. Now I'm going to use momentum before, momentum after for each block. So for the first block, I have mass of the bullet, velocity of the bullet, plus the mass of the first block times its velocity before the collision is equal to mass of the first plus the mass of the bullet, because they stick together, times the velocity of both of them after. And the same I have for the second one, mass of the bullet v sub 0, and then I have m2 times 0 is equal to mass of the second one plus m sub 0, because they stick together, and I have velocity 1. Now I'm going to solve for velocity 2, because it's the second mass. So I'm going to solve for v1 and v2. So v1 is equal to m sub 0 v sub 0 divided by m1 plus m2, or m1 plus m sub 0. And v2 is equal to m sub 0 v sub 0 divided by m2 plus m sub 0. So I found these two velocities, and I'm going to show you where I'm going to use it in a second. They give me delta D, and D1 is equal to V1 times the time, and D2 is equal to V2 times the time. So the horizontal distance, this is the distance D. So the horizontal distance is going to depend on the velocity at which the bullet in block start moving horizontally and the time it takes before it falls down. So I have these two, distance 1 and distance 2, but I know that delta D is equal to D1, length farther, minus D2, length closer, and equals to V1t minus V2t. I'm going to use this formula. I'm going to use this expression that I just found out to solve for the rest of the question. So I'm going to plug in V1 that I just found, and sorry, this is V2, correct? And V2 that I just found into this formula. So what I have is delta D is equal to V1 is M sub 0 V sub 0 divided by M1 plus M sub 0 times the time, so I can write T on the top, and minus V2 is M sub 0 V sub 0 times the time divided by M2 and plus M sub 0. If you can see, they have both in common, M sub 0 V sub 0 time, and what's left in the parentheses is 1 over M1 plus M sub 0 minus 1 over M2 plus M sub 0. Now I'm going to plug in my numbers. Delta D is 0.55, so this part is 0.55, is equal to M sub 0 is 0.01. V sub 0 we're looking for. The time, I just found out what the time is equal to, which is 0.5 seconds. And then I have 1 over M1 plus M sub 0. M1 is 0.3 and M2 is 0.4. So 0.3 plus 0.01 gives me 0.31 minus 1, and 0.4 plus 0.01 gives me 0.41. And now I can solve for V sub 0. So for V sub 0, I will have V sub 0 is equal to, so you can plug in the numbers and see if it comes with the same answer as mine. Mine came up as 139.8, so 139.8 meters per second. But if you do this question online through Montreal Institute of Technology, you Google Montreal Institute of Technology, AP Physics 1, and then there you open momentum, and in the videos somewhere at the end you will see this problem. And they're using 9.8, and they're very, very exact about their numbers, so their answer for time would not be 0.5. I use GS10. They will use 9.8, so their number is going to be different. It's going to be bigger than what I got. So in their answers, this same answer is going to be 132.77 meters per second. And this is the answer you see online, because we did with 9.8. We solved this question with 9.8, not 10 meters per second squared acceleration due to gravity. Let's look at the new question. A force shown in the force versus time diagram in the figure acts on a 2 kilogram object. So the mass of the object is given. Find the impulse of the force, the final velocity of the object if it is initially at rest, initial velocity 0, the final velocity of the object if it is initially moving along the x-axis with velocity of -1 meter per second. So you have two different velocities, rest and -1 meter per second initial velocities. So the force times time is the impulse. So I see here that I have force times time, it's the area, because the height times the width gives me the area. And for the second one, I also can do the area. So the total impulse is equal to the area underneath the graph, which is force is 2 times 1, 2, 3. So that's 6 for this part, plus for the second part is 1/2 the base times the height. So that gives you 1/2 2 times 2, which is 2. So the impulse is equal to 8 newtons times seconds. And then the final velocity of the object. Oh, by the way, you could do it also differently. You could say impulse on the first part is the force times the time. So the impulse on the first part, the force is 2 and the time is 3, so that gives me 6. And the impulse on the second part is again the force times the time. So the impulse on the second part is the average force. You have 2 and then you have 0, so the average is 1, and the time is 2 seconds, so that gives me 2. So the total is 8. So here I can write that the impulse is 8 meters times seconds. And then the final velocity of the object, if it initially was moving starting from rest. So the impulse is equal to the change of the momentum, which is the mass, and change of the velocity. So the impulse is 8, the mass is 2, times change of the velocity. So the change of the velocity is equal to 4 meters per second. Because your initial velocity was 0, so change means final minus initial is equal to 4 meters per second. That means your final velocity is 4 meters per second because initial was 0. Now, if your final velocity, so this was A, this is B, and this is C. Your final velocity will depend on the initial velocity. For the second part, they tell you initial velocity was not 0, it was -1. So because your change of the velocity is equal to 4 meters per second, and that is the final velocity minus initial, which is -1, is equal to 4 meters per second. So your final velocity is going to be 3 meters per second if your velocity was -1 initial. Here is one more question that we're going to do before we're done with this video. 5 kilogram ball initially rests at the edge of a 2 meter long, a 1.2 meter height. So we have 2 meter long, 1.2 meter height. A frictionless table is shown. A hard plastic cube of 0.5 kilogram, so 0.5 kilogram, slides across the table at the speed of 26 meters per second and strikes the ball, causing the ball to leave the table in the direction in which the cube was moving. They say the graph below shows the force exerted on the ball by the cube as the function of time. So I have the graph over there. Determine the total impulse given by the ball. Determine the horizontal velocity of the ball immediately after the collision. Determine the following of the cube immediately after the collision, its speed and its direction of travel. Determine the kinetic energy. Determine the distance between the 2 points of impact of the object with the floor. So here I wrote information that was given. Mass of the first one is 26.5 kilogram and velocity is 26 meters per second. Mass of the second one is 5 kilogram. The distance it traveled 2 meters and the height is 1.2 meters. So determine the total impulse given to the ball. Since we have the graph that shows the force, so they say the force exerted on the ball or by the cube is given. So what I'm going to find is the impulse from this graph. And the impulse again is equal to the area because it's force times the time. So I need to find this area, I need to find this area, and I need to find that area. So let's find the area and calculate the impulse given to the ball by the block. So I did my calculations and I took the average force, which is, and it's given in 10 to the third or kilonewtons, and the time is given in milliseconds. So positive 3 and negative 3 cancel each other. So I have the average force is 1 kilonewton and the time is 4 milliseconds. So kilo and milli cancel and I have 4. And then average force is 2, time is 2, gives me 4. And the last one is average force is 1 and time is 4 again. So the total impulse is 12 newtons times seconds. So I solved the first part. Determine the horizontal velocity of the ball immediately after the collision. The impulse is equal to mass times change of the velocity, and the ball is 5 kilogram. So we have the impulse is equal to the mass of the ball, change of its velocity. So the change of its velocity is equal to 12 divided by 5, which is 2.4 meters per second. And because initial velocity of the ball was 0 and the change by 2.4, that means the final velocity of the ball is 2.4 seconds. Determine the following for the cube immediately after the collision: its speed and its direction. So now we have momentum before and momentum after. So for momentum before, I'm going to say the mass of the first one times the velocity of the first one plus initial. The mass of the second one, its velocity is 0 first. And then I have the mass of the second one times its velocity that I just found. So the velocity of the second one plus the mass of the first one, and I'm looking at the first one velocity of the cube. So let's plug in the numbers. The block is 5 kilogram and moving at 26 meters per second, and the cube, the ball is 5 kilogram and the cube is 0.5 kilogram. I plug in my numbers and I have the mass of the block times its velocity plus 0 equals to mass of the ball after velocity of the ball after, and then mass of the cube to velocity of the cube, and I get the velocity of the cube equals to 2 meters per second. So that means it's still moving forward. It did not change its direction. It's still moving to the right as it was moving initially. The next question, they ask you to determine the kinetic energy dissipated by the collision. So I need to know kinetic energy before and kinetic energy after. So the kinetic energy before is equal to 1/2 the mass of the block times its velocity squared, which gives me 169 joules. Then kinetic energy of both after, so I have to calculate the kinetic energy of the block and the ball after the collision. So here I plugged in the numbers for kinetic energy of the block after the collision, because we found out that its velocity is 2 meters per second, and the kinetic energy of the ball after the collision, because we calculated its velocity is 2.4 meters per second, and I get the kinetic energy is equal to 15.4 joules. So I got kinetic energy after, and I have kinetic energy before, and I can find how much energy was lost. So I just have to subtract those two. I got 153.6 joules. And it is negative because that's the energy we lost. And in the last part, they ask you to calculate the distance between 2 points of impact of the objects after they had hit the floor. Because they give me the height is 1.2, I can find the time it took to hit the ground. And after I know the time in velocity of both, I found out velocity of both in green, I can figure out the distances, how far they landed. So I'm going to plug in the numbers and find those. But I'm going to start with the time. The time is equal to the change of the vertical velocity over the acceleration. And I need to find the vertical velocity, which is the square root of 2ad height divided by 10 acceleration. And I get 0.49 seconds. Since I know the time it takes to land, I'm going to find both distances now. So here I have two distances, and now I'm going to subtract to figure out how far from each other they landed. And I got 196 meters or 19.6 centimeters, which is almost 20 centimeters.